find a value c such that the function is continuous everywhere. So I've got this x squared plus 8 piece that I'm starting out with. So that's some sort of like parabola thing going on. And then I've got this 10x minus 33. And my hope is that I can find a value c such that the first piece and the second piece lock together, because continuous means that there are no gaps. So in particular, I need the limit as x goes to c from the negative side of x squared plus 8 to be the same as the limit as x goes to c from the positive side of 10x minus 33. In other words, the value that it's approaching as it goes this way, this limit x goes to c from the negative side, should be the same as the limit coming from the other direction. They need to meet up. These are really nice continuous functions on their own. X squared plus 8 is great. 10x minus 33 is great. So I can actually just plug in the value c for both of these. C squared plus 8, 10c minus 33. Now, I'm trying to find a c value so these things are equal. So what I'm going to do is I'm going to try to get everything onto one side, and then I'm either going to do something like factor or find the quadratic formula. So I'm going to go ahead and subtract that 10c from both sides. And then in that next step, I want to get rid of that negative 33, so I'm going to add 33 over. And this gives me c squared minus 10c plus 41. And now I'm trying to find numbers that multiply together to give me 41, but add to give me 10. Not that many numbers are going into 41, though, so let's try to use the quadratic formula of this. Quadratic formula says that your values that we're solving for c in this case will be negative b, that's negative 10, plus or minus the square root of b squared, that's negative 10 squared, minus 4 times a is 1, times c is 41. And then on the bottom, I have 2a, a being the number in front of my x squared term being 1. So I'm using the quadratic formula where the first value there is a 1. I'm plugging that in for my a. I'm plugging negative 10 in for my b. I'm plugging 41 in for that c. And I'm going to simplify this. Negative negative makes that a positive. 10 squared is 100. Minus 4 times 41 is 164. All over 2. When I do this, I have 10 plus or minus the square root of negative 64 over 2. I can't take square roots of negative numbers, so there is no real solution to this. Which means if I was hoping for a value of c where that was just a nice non-imaginary number, non-complex number, that's out of the question here because I'm taking the square root of a negative. But if I allow for complex answers, the square root of negative 64 is 8i, I because it's a negative. Dividing this by 2 gives me 2 possible values of c that would make this continuous. 5 plus or minus 4i, dividing each of those components by 2. So there was no real solution to this, but when I set this up here with the two sides being equal to each other and solve, I was able to find complex solutions. Kind of neat. Let's take a look at some more of these problems together.